now. Awesome. Okay, this is my first time trying a live stream. This is my first time doing live coding. I'm not entirely sure how this is going to go, but you know what? Let's just go for it. So, a bit about me. My name is Carlton. I live in London, Ontario. That's here in Canada. I'm currently a C and C++ developer. I'm also the CEO and tech lead of a startup here in town called On Paper. That is a dating management application. Going forward, probably every Sunday, we'll sort of see how these go. I'm going to be doing a live stream of just HackerRank problems. I'm not exactly sure what the style is going to be or how exactly I'm going to organize all of this. So to start things off, I thought I would do my first hour just covering a bunch of C++ problems. We're going to do some easy stuff and take it from there. I'm streaming to YouTube, so I assume that's where you're watching this. So if you are and you're still live, feel free to drop me a question in the chat. I will do my best to answer it. A bit about my programming background. I graduated from Fanchaw's computer programming analyst stream in 2018. I've been working as a software developer for just about a year and a half, 2 years, excluding, of course, the year I spent doing co-ops while I was in college. I work here in town, here in London, as a C++ developer, and I really enjoy programming. And so I thought what I wanted to do was to try to share some of that with you. I'm going to do my best to get this streaming technology working correctly. I have used a computer before. I'm just trying to make sure that this fits onto the screen for YouTube. It's a little bit different. I'm using an OBS streaming software, so it's not quite one-to-one with what you're seeing on YouTube, so I'm just trying to make sure that you're absolutely seeing everything. If you can't, please let me know. Full screen this. That should hopefully make it a little bit easier to see what's going on. There's also a bit of a delay between what I'm doing and what it shows on the YouTube live. So if you can't, please let me know. So I think we are good. Yeah, we'll just assume we're good. All right, so we're going to do programming problems. We're going to do C++. It is my professional background. Also, I do really enjoy it. I don't profess to be a genius of C++. I'm sort of what I would consider to be a solid programmer, meaning I can get my work done and I understand how to do clean code. And I'll just a bit of understanding about what goes into doing something like this. I think probably the biggest obstacle to doing something like this is like, oh my God, people are going to see that, oh, I had to look something up or something like that. I think it's important not to waste one's time worrying about that. Most of the things that we worry about don't matter. Most of them actually are just more in our head than they are. And I think if you sort of approach most things with just an attitude of, hey, I'm learning, I'm going to get better, particularly at doing live coding, it is very different than coding on your own, because I'm going to try and talk through a lot of what I'm doing, and we're going to learn and grow. So this is the very first one. Like I said, we're going to jump right into it. I'm going to try and do about an hour. These will get a little bit longer and certainly more elaborate as we get going, but I sort of wanted to start somewhere. So let's get into it. So this problem is called Say Hello World with C++. Simple challenge to help you practice standard out. So that's output to console. I did do the solve me first problem. That wasn't really a problem. We're starting out by printing the most famous computing phrase of all time, which is hello world to standard output. I don't need to read in any input. That's good. And just do an output. So first thing we're going to do is we are going to include the IO stream because we're going to print to IO. We're going to use the standard namespace. Main is the main where C++ programs run, and then we're just going to do a standard printf. So what happens when we run? Shockingly, it all worked. So, bit of explanation as to why that happened. So, this is a standard printf, which just prints this out to console. This is a string. And return zero in this case doesn't do anything. It's sort of a everything's fine. But it needs that because this function, this main function, expects the return of an integer. So, it runs, prints out hello world, expected hello world, and we're done. So we submit the code and move on. Great. Fantastic. Next challenge, please. Oh, I think that was the header for the next challenge. Basic data types. So, some C++ data types, their format specifiers, and the most common bit widths are as follows. So this is an integer. This is a format specifier, this %d, stands for 30, which is 32-bit integer. Some people confuse the d for being decimal, which they sort of think of as a float value, but that's not the case. D in this case is just for integers. A long d, or a double-sized integer, so we go from 32 to 64. A char is a single character. Strings in C++ are their own data type. I'm sure we'll get to that at some point. Floats are decimals, but they're of smaller size, and then doubles are twice the size of regular floats. And those are also decimal values. So what we're going to do, we're going to read a data type using the following syntax. So this is it. So this is our function scanf. It's going to take our format specifier, that's one of these, which tells it what it's looking for, and then it's going to take a reference to a data type, and that's this value. And so if we want to read a char value or a double, we would say, great. And this is our first specifier. It says we're going to expect a char, then a space, and then a long float, otherwise known as a double. And then we're going to print it using the very similar format. So you might have a string with all kinds of characters, and then it will expect at some point to make use of this value. So if this is your char value, and this is your double value, it's going to print out D into this format specifier, and D into this format specifier from long float, and then CH into the first one. The specifiers and the number of values which are added, that's these, do have to match, otherwise you're going to get it. All right. So, we can use cin and cout instead of print. However, if we're taking in million numbers as input and printing out a million lines, it's faster to use scanf and put. All right. So, input consists of the following space-separated values. Print each element out onto a new line in the same order that it was received as input. Floating value point should be correct up to 3 decimal places, and the double to 9 decimal places is the same. All right, so let's figure this out. I haven't done these problems before, and so we're just going to work through them together. I don't have any sort of special plan. Sometimes when you're doing this, you think you might want to just, well, let me pre-do all the problems ahead of time. That way, I can look like I'm figuring it out. I'm just, sort of magically gifted at programming, and I know exactly how to do it. I don't know exactly how to do them all. We're going to do them together. And that's that. So, what to do? We're going to print an integer 3, followed by a long value, followed by a char, followed by a float, followed by a double. So, and I do have to so I will have this input. I will have to print out this output. So let's deal with the input first. So the input, fortunately, is going to appear all in one line. Oh, what do I need? I need to do a scanf. And well, the first one is an integer, so that's D. Space, there's a long value, so %. And this space, there's the char value. Let's see, yeah, that is %C. Then there's a float value, %F. Then there's a double, %LF. Yep, we've done that correctly. Conversions and data arguments. As I said, you actually have to sort of pass in the actual values you get. So, scanf. This is the one that we normally use. Correctly. So, first thing you have to do is you have to define what average means. Then I'm going to use this. So I'm going to take the ampersand symbol as a reference to this value. So this is the bit I was using. So I'm going to float. I'm going to use it first. So, integer. So let's call this value. Value to be double value. Our value is to be yeah, so this is the part I was missing. So it's going to take root value. This is going to be a reference. This is the reference operator. Char value. This is float value. On float, this is a double value. Great. So, what is the first thing that we did? Hold data. And now we're going to do printfs. So then we can do things like this. Then we can do printf. /n should give us a new line character. So what have we got so far? First thing we did was we defined the integer values, the long values, the double value, the float value, and the char values. So that's the absolute first thing we did. Second thing we did is we read in the data, and we stored all of that. So what's happening is we read in from console this data, and it pops it into each one as they are positioned. So now, by the time we get to here, all of the data is visible, and we can start to use it. So, what is the first thing that we've done? It says, well, I need to print 3, and then, or print the character, the integer character, and then I need a new line, because you can see they're printed on one on each line. So, it's fine. So we do printf, and we do %. This is going to be the long value. You can just do /n. You can actually put this on the same line, but for the sake of clarity, I'm putting it on its own line. Char values, again, fairly straightforward. Float. Now, there was a note about the float value. They wanted it to within up to 3 decimal places. So, there is a way of doing float values. I think it's like this, but we'll find out when I try. In which case, I will just have to look it up. Printf. Value. Of course, we need to change this. All right. Oh, let's see what we get. Did not take what I wanted. I did get rows, that's fine. Yeah, so I was right about the formatter. It doesn't like /n. Strange. Ah, that's it. Ends were facing the other way. Here. Here. Let's run this and see what we get. Nice. So, this is all good, and you can see here that the way we did the decimal specifier for floating point values is just use a percentage, then the decimal place, and then your level of precision goes here before the variable type. So that's all you have to do there. And you're good. And we move on. Apparently I've also earned my first star. Thanks for me. On to the next one. Let's do conditionals. So, we're going to talk about if statements and else statements, two of the most frequently used conditionals in C++. Very true. So basically what they enable us to do is to establish what you call a logical flow through a body of code. So you can sort of decide, it's a bit like a flow chart if you've ever used a flow chart. So what ends up happening is you can do things like say, okay, we're going to go, if this happens, then do this. Otherwise, do this if this happens, or if none of those things happen, then do this. So that's the if statement, the if-else statement, or excuse me, or the else-if statement, and then the else statement. So there are sort of three ways of looking about it. An if conditional just says, hey, if this is true, do this thing. An else if says, if the first conditional, the conditional previous to that, was false, then check this one. However, if the first conditional is true, it will not run the else if statement. But if you have two if statements together, it'll check both of them. So just something to be aware of when we think about conditionals and how to use them. So do this. Actually, I want to move this window set to the side. Oh no, I guess that's big enough. I'm just looking at it in YouTube, and I think that's probably fine. I'm just going to give it a second here for the stream on YouTube, which is a little bit delayed from what I have here. So that's the wrong direction, and it should go back the other way shortly. There we go. Okay. I guess that's all right. It's too small, I'm sure someone will tell me. That should be. Okay, we'll move on. So, getting back to this. So, if statements and else statements, we do use them a lot. We also use a switch statement a lot. So depending on what you're doing, you might find that the switch is really what you want. Because the switch will let you do conditional, but in like a really clean way, but it depends on what your input is. I'm sure there's a switch statement example, so we'll talk about it when we get there. So let's go through this. We're now doing conditional statements in C++. So if and else are the two most frequently used conditionals in C and C++, and they enable you to execute 0 or 1 conditional statements among many such dependent conditional statements. We use them in the following ways. If this executes a body of bracketed code starting with statement 1, only if this is true. So basically what that means is you have an if statement and then braces. If this condition is true, the braces, whatever code in here will get run. If this conditional is false, the program will skip over this onto whatever the next lines are. When we talk about if-else, what we're saying is if this conditional is true, then do this. However, if this conditional is false, this code here will automatically get run. So I hope that's fairly clear. And then when you do an if, else if, and else, it gets slightly trickier, but basically what's going on is if this conditional is true, do this thing. If it's false, check this conditional. If this conditional is true, do this. Otherwise, check this conditional. If the first conditional is false, this conditional is false, the third conditional is false, then run whatever code is in this default. However, if any one of these conditionals get run, it will skip over to the end of this statement. It will skip this final else. So these are all mutually exclusive. So if this conditional is true, these ones will automatically not get run. They'll be assumed to be false because of how it's set up. If this conditional proves to be true, it will skip the second and third condition. So that's basically how it works. All right, now I think one of the easiest things to do is to sort of like gloss over some of this stuff. It's a really bad habit of mine, of just like, yeah, I got the general idea. But it really is important to really take a look and see what exactly it is it's asking us. So, if 1, this is less than or equal to n, which is less than or equal to 9, which means n can be 1 all the way up to n including 9, but it cannot include 10. If n happens to be greater than 9, so anything greater than 9, you just print out greater than 9. Let's look at the input. We're just going to get one integer. That's it. Now, what do we know about this integer? It will be greater than or equal to 1, which means it will not be 0, and it will be less than 1 billion. All right. Then, if n is between 1 and 9 inclusively, so that includes the n including 9, then print out the lowercase English word corresponding to the number. Otherwise, just print greater than 9. So if the number is 5, you would actually write out F-I-V-E for 5. But if the number is 44, you would type out greater than 9. Great. So now let's look at how do we go about doing this. So these are stream operators. So this takes input from the console and inserts it into this n die. So n here is just declared, but it doesn't receive its actual real value until this line here. And you can sort of see the arrows kind of helping you understand what's happening. You're inserting the value from the console into this n value. You'll also see this comes up when we go the other direction when we're doing C out. So C in will go left to right, and C out will go right to left. And that's fairly all there is. Fairly all there is to that. All right, so let's do it. So we've got some things. So we know that if n is equal. So all right, let's just start in a really naive way. We know that if n is equal to 1, we want to do C out. N line is not necessary. What this ends up doing is this just spits out a new line character. So if they had them one on top of the other, each time one of these gets printed out, it would be printed out on a separate line. So if n is equal to 1, you could do this. Now, is there a reason why you would not do this? This will work. There's a reason why you wouldn't code like this. And if you're curious as to why, ask yourself the question. If n is equal to 1, will n ever be equal to 2 in the same running operation? So if n is equal to 1 here, will it be equal to 2 here, or 3 here, or 4 here? I think you probably get the idea where I'm going with this. It won't. So what we can do here is we can say so we use the else here. And the reason why we use the else is because if any one of these things is true, don't check the other ones. And that's the point of the else if statement. Six. So, by the way, this is what happens when you talk and code at the same time. So then going back to here, if you want to take a look, is 9 going to be included in one of our conditionals? And if so, why? So, if n is less than or equal to 9, then print the lowercase letter. So, then yes, 9 will be. And then for everything greater than 9, okay, this bracket is not necessary. Default Let's run the code and find out how we did. Great, so it all works. So, what happens if the user submits something we don't expect, like -1? What happens? So, looking at this conditional, what does it do? If you said spits out greater than 9, you'd be absolutely right. So that's okay because given the instructions in the problem that we received, they told us don't worry about that. We know the limits of the n value, that it is between 1 and greater than 9. However, if this were a real problem, you do have to ask yourself, what if the input that I expect from the user isn't, what I expect? I don't receive what I actually expect from the user. And so you do have to code for that. So in this case, you would need to code for, hey, if n happens to be less than 1, what do you do? Yeah, just something to keep in mind when you're writing code. You always want to be programming defensively, certainly as much as you can. And we're on to the next one. So, we're going to take a quick look at for loops. So for loops are something you use a lot. There's a very good sort of way of thinking about for loops, and because there are other types of loops which you might be aware of. There are for loops and while loops, and the best way to think about it is if you know how many times you want an iteration to occur. By that I mean, if you know how many times you want a loop, you want a piece of code to run, let's say you're counting to 10. If you know exactly how many times you want to do that, then you want to use a for loop for that. However, if you're not sure how many times you might need to run it, and you don't know exactly when your conditionals will be true, then you want to use something like a while loop or a do while loop, which is functionally the same thing. And the way to think about a for loop, they have it here. So you can see that they've got these 3 expressions here. So the way to think about it is this initializes your loop counter, this is your looping condition, and this is your increment statement. So what you want to do is you want to say, hey, integer I is equal to 0. So that's the way you set this value. Then you want to say, hey, keep running the loop so long as this is true. So long as I is less than 10, keep running the loop. Now, if you don't have this line here, and you run this code, this will run forever. Because unless I is somehow being incremented, this condition will always be true. And you'll be stuck in an infinite loop. This happens less with for loops because of the way we learn them and how they're structured. But in while loops, this is almost always a problem, especially in the beginning. It means that like you set up a while loop and you're like, how come I never leave? Oh, right, because my conditional actually isn't incrementing the way I think it is. Or it's not incrementing at all because I forgot to set it to do that. So just something to keep in mind. The first part, you're initializing your variable. Second part, you're checking for the terminating condition. So long as this is true, it will keep looping. Then you want to check that you're actually doing the update. And again, this is optional here. You can do it in the code, but this is the general structure of doing a for loop. Okay, let's get back to the problems. So, input. What are we expecting? We're getting 2 positive integers where a is less than or equal to b. All right, then they're going to be separated by a NOR. And then let's look at the output. For every integer that we get within this interval between a and b, so this is integer n, so this is going to be what we're looping in. If n is less than or equal to 9 and greater than or equal to 1, then you want to print out its English representation. If n is greater than 9 and it's even, then print that it's even. If n is greater than 9 and it's odd, then print that it's odd. So, very similar to what we just did, but a little bit more complicated. So, as always, whenever you're sort of facing these types of problems and you're like, I don't know exactly what to do, you know, and you start to feel that nervousness start to creep up into you, you're like, I don't really, I kind of have an idea. Take a deep breath and just start. Better to start coding once you've given it some thought, but better to start coding and rather than sit down and hyperventilate because you're like, oh my god, I don't know how to solve this problem. You'll figure it out as you go. It's like what they say about recursion. You know, it takes a leap of faith that the code is doing what you hope that it's doing. Hopefully there's some recursion in this, although there's only 25 minutes left in this stream, so I don't know. We'll probably won't get to that today. But if you're enjoying this, by all means, leave me a comment, stuff you'd like to see, and we'll just keep doing more of these. And I'll probably do them every Sunday, and we'll just keep rolling. We'll just keep rolling. We'll keep talking about code. We'll keep getting better, and that's how we're going to do it. So it's fun. So two positive integers, A, B. All right. So what do I expect? I expect input to be a start and an end. So first, I know these are integers. This is start, and I also could have done this. That also works. I've got to stop pressing Control S. It's a super bad habit. I do it because when you're on like Visual Studio or something, you're sort of used to saving as you go. Okay, so I'm going to do an insertion operator. Start. Insertion operator into end. I think that should work the way that it is. Because I'm using stream operators, once it hits a new line, that should be the end of the stream. So I should be able to use cin and then later cout and use exit. So, but we'll see. If it's, you know, again, as with most things, if it's not quite the case, then we will fix it. So, once we have our start position and our end position, we want to move our counter from the start position to the end position. And then we want to test what values are inside. So that's what we're going to do. So we're going to do a for loop. For an int I is totally a convention. It could be j, it could be k, it could be counter. It doesn't have to be I, but almost every textbook uses I. Everyone learns starting with I, and so it actually is quite easy to read once you see it in the code. You just want to be careful that you understand there's nothing magical about I. It really could be anything. Because sometimes you will need to use something else, or you'll need to use two counters or something of that nature. So now I is equal to 0, and then I is less than end plus I. That's sort of the form that we're used to, but this is wrong. I don't know if everyone can see why this is wrong, why this is not what we want to do. We know that when we have a for loop, we start I equals 0, I is less than the end position, and then we just increment I. Also, I'll explain that a bit in a minute. So, a couple things to check. So, the intervals are A and B, that's fine. This is the bit that actually we care about. Because first thing I need to know is, so you see this x value. So x is an element of integer values. Great. But this is the part that tells us how we can use, how to set up this for loop. So x has to be less than or equal to b. B is our end value. So less than or equal to. So first of all, this is wrong. Because if our end value is 10, this loop will only go to 9. So first things first, I need to do this. And now the start value. Well, let's look. The start value is actually less than or equal to A. That's our start. This is 0. That isn't correct. So, let's read this again. So, for every integer I, where I begins at the starting position, so it includes the starting position, and it checks, is the starting position less than or equal to the end position, which means it'll run right to the end position, and then it checks for I. And then plus plus I instead of I plus plus, it really doesn't matter. All you're saying, so with I, in this case it doesn't matter, sometimes it really does matter. So with I plus plus, what you're saying is you're going to return the value of I to the caller and then increment it. And then with plus plus I, as you probably guessed, you increment the value of I and then you return the incremented value to the caller. But for our purposes, whether you increment and then return or return and then increment, all this happens before the loop anyways, so it really doesn't matter. So, but plus plus I, my understanding is it's a little bit faster to do it that way. So that's what I do. So now that we've sorted that out, we have a correct range. Now what are we supposed to do? We now need to do the same thing we did last time, so we need to print from 1 to 9, and we need to do it that way. So let's see. Maybe instead of if statements, let's do something else. Let's do a switch on I. We could have done this with if statements, but we just did that, so why bother? So, case 1. And we know that the E and B values it only works for values greater than or equal to 1, so we don't have to worry about 0 or less than 0. So you might be thinking, so let's see if this structure is going to be what I know. So, as you probably guessed, in here is going to go let's stop pressing space. So, for every value that is between 1 and 9, it will go ahead and spit out this value, spit out this print statement. So we know this will work for 1 to 9, that's great. But now, will this be correct if we need to check for values greater than 9? Well, I'm not going to do case statements from 1 to 1,000,000. I could do this. I can do default statement and then have and then do a check and see if it's odd or even. Now, there are a couple of things. There's a couple of things that I like about this solution, a couple of things I don't like about this solution. Number one, it is super straightforward what's happening. Like, it is very, very clear what's happening, and rather than having all these if conditionals to worry about, I can just do this. Now, where I dislike it a bit is that I now have a kind of general default, where I'm now saying, okay, if it's odd or if it's not 1 through 9, then do a check if it's odd or even. Whereas if I was doing this with if statements, I would be able to say, okay, use a definitive if statement, like use an if greater than 9, then do this. So what I can do, I am actually going to keep this format because I think it is fairly clear what I want to have happen here, and I think this is pretty readable. So, and a bit about the case statements. What do you think will happen if I don't have these break lines in between my code? Like, what do you think would happen if I was just like, you know what? I don't want to write in all these break statements. I just want to just leave the code. Just have case 1, case 2, case 3, case 4, case 5. Maybe put a break at the bottom. What would happen? If, let's say, our value was case 1. Sorry. So, let's say my value was case 1. And then I said, hey, you know what I'm going to do? I'm going to not have these break statements here. You know, what do you think would likely happen? If you're saying that case 1 would then fall into case 2, which would then fall into case 3, which would then fall into case 4, you're absolutely right. If you didn't have these break statements here, what would happen is if you had case 1, it would actually print out 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to the bottom, and including the default if there was no break statement here. So the break is super important, but you can see that, like, if you, let's say you have 2 cases but 1 outcome, then you can do this. Now, if you had case 1, it will execute case 1 code and execute case 2 code. So that's the thing you can do. You could also move this like this. So case 1 or case 2 just runs this code and then hits the break. So you do have some flexibility, and sometimes you don't use it all the time. We try to avoid doing unusual things. You never want your code to be surprising if you can help that at all, but sometimes you do need to do something a little bit different when handling these problems. And again, there are a lot of ways to do this. We could have done this with if statements. I'm just choosing to do it as it occurs to me live. So, what have we done? We've declared 2 integers for start and end. We now insert using this insertion stream operator. We insert the value into the first value to start. We insert the second value into end. We now set up our for loop so that it starts at the start value, ends including the end value, and increments by 1. It comes into here and it says, okay, depending on what value is in this, it's going to execute one of these case statements. If it's 1 through 9, that's what it does. Great. But that's not all. Now, if it's greater than 9 and it's an even number, then type even. If it's a greater than 9 and it's an odd number, then type odd. Okay, so fine. So whenever you see even and odd, you always want to think modulus. You always want modulus 2. And the reason for that is because modulus, every odd number, as you probably understand, every odd number divided by 2 leaves a remainder of 1. So if you have a 5 and you're doing division by 2, you're going to end up with 1 as the remainder. And if you divide an even number by 2, you will get 0, no remainders at all. And that is very fundamental. So whenever you see odd or even anywhere, you know it's going to be modulus 2. So now I want to be a little bit smarter about how I do this. So I want to actually check if I is greater than 9 and I modulus 2 equals 0, then I want to go ahead and put that on. Else, yeah, thank you. That's fine. Okay, so we've read through the code, we feel pretty happy with it. Let's go ahead and run it and see if we missed anything. 8 and 11. So they were expecting, I'm pretty sure it's pretty obvious why this code has failed. If I modulus 2 is equal to 0, then this is not odd, is it? It's even, That's rewrite it. And we're good. So, yeah, so this was a solution for doing this. Again, there are a number of ways to solve a problem like this. You could have used if statements. There are probably even more clever ways to do it. But these are good approaches to solving problems and to see, okay, how do I get this stuff done, and how do I think about it, and how do I understand how to do this? No, thank you. I don't want to solve. I want to share this with friends. I'm already sharing it with people. Run it before we let me out of here. Great. Next challenge, please. I think we have time for probably one more in the hour, and then we'll call it for today. And then next Sunday we'll come back and we'll do probably quite a bit more. Yeah. So let's talk about functions. Functions are basically a bunch of statements glued together. A function is provided with 0 more arguments and executes statements based on received parameters, and depending on its return type, it will do some things. I'm going to skip down a little bit to the actual task, and we'll talk about what functions are and how they work a little bit later. So I have to write a function. It is called int. This is the return type, so I know I'm returning an integer. Max of 4 is the name of the function, and I know I'm receiving 4 integers. So I'm just going to read in 4 integers and then return the biggest. Plus equals is the assignment, as the add and assignment operator. So it is the equivalent of a is equal to a plus b. So we'll talk a little bit about how that works. All right, input will contain 4 integers, that's fine. Print the greatest, blah, blah, blah. So let's take a look. The reason why I skimmed that a little bit, even though I said it's a bad habit, which it is a bad habit, but I did it anyways because it doesn't matter in this case, because all of this is being handled by the testing solution. But again, we can look at it and say, okay, we declared our integers. We use scanf. We assigned a reference to each of those integers here, so that when scanf scans in the value, it puts them into these integers. Then it's going to pass these integers into this function. Now, the reason why max of 4 is under red underline is because we haven't written that function. So the first thing we'll do is write out the function signature. So we know it returns an integer. We know it's called max of 4. And we know that it takes takes 4 integers. So now everything is happening. Great. Now, it's also red. It's red because it wants a return value int of 4 is equal to, let's just say arbitrarily, is equal to a. There we go. So, what have we done? As of right now, this function takes a value and it compares it to all of the subsequent values. And well, as of right now, what it does is it takes a value. It takes 4 values as parameters. By the way, these are passed by copy. Right now, that doesn't mean anything, or it might not mean anything depending on where you are in your programming journey. But these are just passed by copy, they're not passed by reference. And so what that means is, so let's say I go ahead and I change this a value, this value is not changed. We'll probably talk about that a little bit later, but it's one of those peculiar aspects of functions that can sometimes trip people up. So, okay, so how are we going to do this? I have no idea. There are a couple of ways that right off the bat, I think, okay, well, I've got 4 integers, I've got the first one. By the way, the reason why I didn't assign this to 0 or something else is because 0 isn't one of these choices. And I know that max has to be one of these choices, so I might as well just assign it to the first value, as opposed to giving it yet another value, which I know I can never use because that's not one of our choices. So, I now need to compare A to these other three values. Now, I can do something like this. So, and this is the way you should always, no, not you should, but one of the ways you can think about solving coding problems. You can say, okay, I don't know exactly what to do, but I can do something. I know I can do something like this. If max value is less than B, B value is B. You can kind of see what I'm doing here. There we go. So I can do something like this, and this will work. So max value is A. If A is less than B, guess what? Max value is B. If max value is less than C, guess what? Max value is equal to C. If max value is less than D, guess what? Max value is equal to D, and then return max value. This will work. But what if you had a dozen other integers? What if you had 100 integers and you're trying to find the max? What if it was max of 4,000? This solution, as you can see, is not going to scale that well. So while this should solve the problem, and maybe I should just go ahead and check that. Yeah, so this solves the problem just fine. It's a completely valid solution, but anytime you start doing something like this, alarm bells in your head should start going off. It's like, there's got to be a better way to write that. Because, and the reason why this should run alarm bells for you is because this is basically the same code. Again and again and again. You're doing the same check multiple times. It's like, huh. Same code multiple times. What if I took advantage of the fact that I know a couple things about this data? I know there are 4 of them, and I know they're all integers. I know that I need to go through them all, and I need to do a check against a value. So, what can I do that might make sense? Now, again, there are only 3 values. There's nothing wrong with what I've done here, but is there a better way? Well, let's find out. Like sometimes in programming, it's just this. So let's say we have a vector of ints So, a vector, we can probably talk about it, but a vector is just basically a container that I can use where I can go from beginning to end. That's all that's going on. So, with my vector that can hold all these containers, I can do this. I can then do something like v.pushback. And actually, I don't need a, because I already have a. v.pushback. C v.pushback. So, I now have a vector. It holds 3 values, B, C, and D. I have a comparison value that I'm using. So now what I want to do is I want to, instead of having this check being done in 3 different places, I want to just do it once. So let's take advantage of what we know. I know that I have a for loop that I know exactly how many times I want to go through this loop. I want to go through this loop exactly 1 time per element. So I is equal to 0, because that's going to be the index of this vector. So that'll be this B value here. This B value. That will be index 0. This will be index 1. And this will be index 2. So I is equal to 0, I is less than v dot size. V dot size will be equal to 3, and I want to do less because I actually want, because again, index 0 is this, index 1 is this, index 2 is the last element. If I were to say less than or equal to v size, which is 3, there is no index 3. Index 3 is actually the 4th element. So it's a bit much to think about, but don't worry about it. You just want to make sure that you're doing less. You just want to make sure that your indexes are all valid. And then, of course, you need to increment the operator. Great. Okay, so I now have done that. So now I'm moving from the front all the way to the end. And each time I want to do basically this. I want to say if max value is less than v at I, then max value is equal to v at I. And this is it. So, and then I can get rid of all of these things. And that's generally how you know when you're starting to get a solution that's going to be a little bit better. So what have we done here? We have a function that takes 4 integers. We save the first integer arbitrarily, it doesn't really matter, as max value. We store the rest of the data into a container. Now the only reason why we put it in a container is so that we can iterate through it very easily. And that's what we do here. We iterate through it very easily, and then we do this check. Now let's go ahead and run the code. And it works. Great. Now, we can actually do something even more interesting. So right now we're using the standard for loop, and that's fine. But what if we wanted, but we already know we need to go through every element. So all of this checking, less than size, check, we don't really need to do that. So what we can do is this. We can just say, okay, what if instead of I, which is short for index, if I were an element? And you're like, oh, wow, okay, so element is what? It's actually the value being held by the index. So we're no longer getting the LV of I, we're just checking the element. And so in that way, we've simplified the code quite a bit. And when we run it, we should get the exact same thing. And we do. So we've sort of seen how we can do it. And now, even though this is max of 4, and that's fine, it says 4 in the title, if for some reason in the future we need to have 4,000 elements, well, chances are they're not going to input them all individually. Chances are they're going to give it to us in something like this, in something like a vector. Well, now our code is very well suited with only minor changes, where we can say max value is the first element of whatever vector they hand us. Then we actually can even skip this. We can actually just iterate through, like all of this can be eliminated, and we can just iterate through the vector that they give us, and then return the max value. It is much, much faster. And that's it. We can submit our code. Should pass, and we're good. And so you can see, this is like a fairly straightforward, I'm now up 10 points. It's a fairly straightforward way to start thinking about coding problems. This is actually, it's a little bit nerve-wracking, I know, when you're starting problems, and it can become very mentally challenging to start thinking about, okay, how exactly am I going to do this? How am I going to make, what if I don't understand? What if I get stuck? Maybe I'll wait till later, all this kind of stuff. But really what you want to do is just sit down and get started. And once you're through that, as you can see, it's really not that bad. But that's my time. Thank you very much for sticking with me, and we'll see you next time. Cheers. I'm going to pull a Sam Cedar and say, yeah, go away while I figure out how to turn this on.